Welcome to Shavi Academy. Welcome to Shavi Academy. Today we know about solar energy management and forecasting system. Main objectives of this project is to monitor solar power generation and analyze household energy consumption, and it is very forecasting for the future solar energy production, and it calculates carbon emission savings also, and it provides a smart energy management insights, and it encourage renewable energy adoption through reward points. The main problem statements of our project is residents cannot easily track real-time solar generation, and it's no clear comparison between appliances consumption and solar productions, and it has no forecasting mechanisms to predict future energy generation also. The lack of awareness and about carbon emission savings. Here we have mainly two modules in our project. Okay. Coming to our user interface, our project. It is the user interface, our project. Here we have mainly two modules, admin module and residence module. It is the admin login page. Here, the admin can log in with the default credentials with the username and password like admin. After the admin successfully login action, here the admin have here the battery monitoring, solar panel status, and system maintenance and energy reports in graphs. Like here, the admin can view in graphs solar forecasting. Yeah, it is 48 hours PV forecasting. Okay, and admin can also see generations for the forecasting graph, like this way interactive PV generation over time here, and also here the admin can view appliances graph for electrical survey. Yeah, it is the total appliances wise energy consumptions of all residences are stored here. Okay, and here the subscriptions have admin. Okay, yeah, here the subscribers. Okay, the subscribes of these subscriptions. The admin can view all the subscribers details. And coming to residence module, here the residents can register here with their personal details like his name, email, password, and address, like this one. After the resident's successfully registration, the resident can log in with their registered email and password. Okay, like this way. Okay, the successfully login action, the resident can log in into the website. If we can give a wrong and credentials, it will be reflected into invalid logins details message page. At the same time, after successfully login action of resident, this page will redirect to residents. There, the resident can view all the solar panel efficiency form. Here, the resident can enter his city name and his panel area, and this is panel efficiency like panel details. Here, the residents can choose and fill his lat longs for the required area and submit total details of his solar resident solar efficiency in the form. Okay, after successfully giving here, the admin can add his home appliances here. Okay, like air condition and voltage and how many hours. Here the admin can apply his home appliance after successfully completed his assigning home appliance. Then he get total details. Then also here the then he can get bill also like this way. And here the resident can select the residential type also. Okay, and can get a region also, like then he click on pay bill. Okay, like this way. After successfully paying the bill, every month, like this way, the resident can paying the bill. Okay. Here the resident can choose admin subscriptions, and here the resident can choose one subscription to follow here. Okay, it is a project. It is our admin module. Here the admin can log in action, and here admin can view all graphs and dashboards. Here the admin can view all register residents subscriptions list for the subscriptions and energy analytics graphs. Okay. Here in the resident module, here the resident can view all the subscriptions of admin. And here in the solar panel form, here the resident can view. And also here the resident can pay the add his resident details and paying bill. Here the tools and technologies here the user for the solar system is the Python is used for the backend, and the framework is Flask. For MySQL is used for database storage. And here we use the weather API to fetch real-time weather data and the temperature, cloud cover, and sunrises, solar calculations. And here we use it PBLIB is used for solar radiation and estimated hourly solar power generation based on location. And here the ProHead is machine learning. It is used for in the graph 48 hours of calculations. And NumPy and Pandas is used for CSV file reading and calculations. Calculations in our project for before paying the bill. And preparing data and forecasting the graphs. The plotly is used for to generate interactive graphs for the solar generation, appliances, consumptions, and forecast visualizations also. And here the HTML CSS is used for the front end. Here we use it. It is mainly used for to design, to develop our website user interface and to dashboards, the forms and graphs by user. This HTML and CSS user friendly. Here we use it to develop. And the final conclusion of our project is a smart solar energy monitoring and forecasting. It compares production and the consumption efficiency. It promotes sustainable and eco-friendly energy is usage. And if you want this project, I can modify this user friendly, your requirement based. And for more about this project details and machine learning details, the tools and technologies, what I am used for this project, and totally I mentioned in the description. Thank you.